recording the session. This is lecture 5 for algebra. This is webcast for lecture 5 and midterm review. This is a review for midterm 1. And I am switching the screen over to Miss Karen.
Okay.
Hold on.
Let me click on the show my screen so you guys can see what I'm writing. Let's see. Okay, show my screen. Remember, there's a delay, so it might take a sec for it to show up, but it's coming.
Perfect. We can see it perfectly. Thank you so much. I'm muting myself out.
Okay, have a good one. So, hi everybody. We got a good turnout this morning. I'm so glad to see some familiar names. Let's see. I want to begin by letting you guys know that I appreciate your patience too while I'm trying to get all your grades up. And so right after this, I'm going to be posting some more solutions, like Mrs. G said. So they're coming up slowly but surely. I'm trying to get at least all your solutions up today so that you can go and review and look over your work, and you'll know what you need to work on. For the most part, everybody is pretty great. I mean, I trust you guys as far as looking over and comparing your work to the solutions. And of course, if you ever find a mistake in my solutions, you're welcome to question anything. I think it's wonderful when students question things. It's okay. It shows me that you are thinking on the critically. You're thinking about how can I solve this, and it's a good thing. So don't be afraid to ask me, you know, is this right, or is there another way to do this? We're getting into the part of the class where there are more than one way. There's more than one way to do things, and you're going to see that as I post this next set of solutions in lecture 3 homework and 4. Sometimes I've written a little note like there's more than one way to do this, you know, but for time's sake and for space on the paper, I kind of just put one. Of course, if you want to ask me about yours, if you've done it differently than me, go for it, okay? So I encourage that, and as I'm giving you guys examples today, I'll try to show you the different ways to accomplish, you know, some of these examples. Anyway, excuse me. So let me get my printout here. I'm going to take some examples and give you guys some examples that will help you guys with the lecture 5 work. And what you're looking at in lecture 5 would be more inequalities. Kind of talked about some of this on the last time we met, but we didn't get very far. We kind of just did. Let me kind of go back and show you what we've done here, if you can see me. Okay, we kind of looked at these double inequalities, and I think this might have been one that I did. Oh, that's just the setup. Okay, this was just an example to show you how to set some of these up. Okay, and anyway, I showed you guys that there is, of course, absolute value, and I call it mess, just because this is where the expression containing x is going to be inside of this absolute value symbol. Okay, so you'll have a couple of things that could happen. Okay, you could have the absolute value portion, of course, once it's isolated. Then you can begin what I'm doing here is the setup. And I'm going to show you what I'm talking about in an example right after this. So the mess containing x is an absolute value less than a. So if you have less than a real number, positive real number preferably, you then begin to set it up in this manner. You have an interval. Okay, my ink pen, of course, wants to have fun today. We'll have the negative value, the opposite of a, less than whatever's inside of the absolute value symbols. That's why I wrote mess, is because you don't change what's inside of the absolute value symbols. So whatever's in there, you leave it in there. You leave it as it is. In this example here, I have the absolute value of 2x plus 4 is less than or equal to 3. Notice whenever I set it up, when I brought it down to the problem, 2x plus 4 does not change. I change what's on the other side of the inequality symbols, you see. Okay, and same goes for the greater than too. Okay, so this becomes this interval and then less than positive. And okay, on the other side then, if we have the mass greater than A. Okay, so if we have greater than, the solution looks a little different. In the less than A, our solution's this interval. It should look like this. It's going to be between, you'll shade and on the number line between two values, the two solution endpoints. If we have greater than, though, it kind of goes outwards. In other words, less than the negative and greater than the positive, okay, as I have shaded here. So we set it up like that, okay? We're going to have the mess, whatever's inside of the absolute value, mess less than the opposite of A, and then the mess greater than the value of A as it is, okay? All right, and that's what I have here, less than the negative, and then greater than the positive, and you'll notice that the 2x minus 5 in this example did not change. Notice it stayed the same when I set it up. See, you set it up and then you begin to solve two separate inequalities. Okay, so let me go to a nice fresh page and let me see what questions. I have some hands up. Let me see what you guys are asking me right quick, and let's see. Okay. Okay, you can't hear me? Uh-oh, okay. Let's see. Let me put this microphone closer to me. Is this better, you guys? Okay. Oh, it might be an internet connection thing. Okay. Stephanie, let's see. Try, of course, try your volume, but maybe you have something muted, or try to unplug and replug your wires. Try that. It could be your wires. So sometimes when you unplug and then replug in, it'll connect better. So hopefully someone can help you. Let's see if anybody has an idea about that, maybe chat box it with her to help her. Okay. All right. So let me get us a warm-up question. Everybody else, say okay if you can hear me. You guys in the chat box, can you do that for me? Just type okay in chat. Let me know you can hear me, if you don't mind, everybody. If you can hear me, type okay in chat. Just want to make sure you can hear me. Okay. Hello? Let's see. I'm going to type that. Okay. Oh, good. Okay. Oh, the questions box is fine. All right. Good deal. Let's have ourselves a little warm-up problem. And yeah, I tend to turn my head away from the microphone sometimes, but you should still be able to kind of hear me. Okay, we're going to just have a warm-up problem. This is going to be just solving. Let me minimize that. Okay, we're just going to solve an equation, okay, for our warm-up. Okay, and let me find one that's pretty near to what you guys have looked at before. Let's take one with a fraction where we have to clear fractions, just to kind of review that since we have a midterm. Okay, so example will be to solve, of course, solve for x, solve the equation. Okay, let's do this one. A 1/2, okay, parentheses, x minus 1/3 equals 3/4 minus x over 6. Okay, so this is a good warm-up problem because we just want to get our brains thinking mathematically. So hopefully you guys are kind of doing this problem with me, you know, alongside me. And if you're looking at this recording later on after the fact, even pause, maybe go back and pause once we write the problem and then go to solve it yourself. That's a good thing to do too in a lot of the videos that I've been posting on the YouTube channel with examples. Now what we need to do here is we need a common denominator, okay? We want to clear the fractions out of here, out of this problem. I mean, you could go ahead and sit there and distribute and then get everything over the common denominator. You know, that would be a lot of time, though. I think this is a wonderful thing to know how to do this skill I'm about to show you, and hopefully you guys have been utilizing it quite a bit, I'm hoping. So let me see, where is this? Let me put the hands down. Okay, I'm putting all the hands down for now, so now you guys, I can know if you're really asking current questions. Out of 2, 3, 4, and 6, we need the least common multiple. So we want the least common multiple of 2, 3, 4, and 6. That's the best common denominator you can use. It's just in any case where you need a common denominator, the least common multiple is the preferred thing. Okay, and out of all these, I believe, let's see, 12 is what we need. Yes, it is. Okay, and so we'll use a 12. If you need a review of how to find that, how to find the least common multiple, let me know later on. Okay, and so you know, I'll go ahead and make sure you get that. So, okay, so a 12 will be what we'll use to clear the fractions. So let's go for it. Okay, so what we do with that 12 is this, and I'll just kind of cut to the chase. I'm going to write the step where you can go ahead and cancel. We take a 12. Now look at how the left side is written. I'm going to wait to distribute. It'll be a lot less time because I can just take the 12 to the front with the 1/2, and then I can leave that x minus 1/3 in the parentheses after. You know, so I don't have to even go into those parentheses just yet. Okay, I should have made that one a little taller. So that's kind of handy. You can wait to do your distribution until after you've kind of brought that common denominator in. So if on the right side though, if it is in single terms like that, what you can do is multiply the 12 times each term, okay? And let's see, we'll have a 12 times the second term. Now watch what I'm going to do now. Okay, so I'm going to put the 3/4. So I'm going to have 12 times 3/4, bring that sign down, and then I'm going to have 12 times x over 6. Okay? I kind of left a little too much space out in the front, but that's okay. So now let's go ahead and cancel. This is 12 over 1, right? 2 goes into itself once, into 12, 6. Now watch what we have. I'm going to wait to distribute one more step. I'm going to have 6 times the x minus 1/3. This 1/3 we can take care of afterwards, so don't even worry about that just yet. I totally forgot about that, but we don't have to worry about it just now. 4 goes in itself, goes into 12, 3 times, so 3 times 3 is 9. Okay. 6 into itself, into 12, twice. So we have the 2x. Now let's go ahead and distribute. This ought to help you guys. Now watch what's going to happen. On the left side, to get rid of parentheses, we distribute the 6 to each term inside of the parentheses. Make sure you're distributing thoroughly. Okay, so 6x. Now watch what happens with that 1/3. We're going to have minus 6 over 3, which is 2. So it worked itself out. Now, 9 minus 2x on the right. And now we can start moving our x terms to the left and our constants to the right. Of course, you want to add the 2x to both sides. And if you kind of have been practicing, I think we could go ahead and just kind of take care of everything in one felt swoop. So we're going to have 8x here on the left, and then we'll go ahead and just add the 2 to both sides at the same time. Okay? After you've done moving everything to the appropriate side, here's what it should look like. These guys cancel. Okay, and you'll have 8x is equal to 11. Okay, so let me know if I kind of have an oversight about anything. You guys keep me posted. I spilled a drink in my lap earlier, so, you know, anything can happen. Okay, so we're going to divide both sides by this 8. And let's get this. And so now x is equal to 11/8. All right. To check, how would we check? If I gave this to you, you would go back and plug in 11/8 into where there's an x value, and you should come out with a true statement. I'm not going to take time for that right now because I want to get to the absolute values. Inequalities, there's a certain type I need to get to for you too. Okay. Let's see. And yes, I want to do some of the word problems, but I hand-picked some of the word problems for you. So let's kind of go to part B. Let's do this one. Now, this will be an absolute value inequality, sort of like what we looked at last time. Okay. Let's have a look at, here we go, absolute value. Okay, here we are, 2 minus 3x. Now this is an equation, it's not an inequality. So, oh wait, I forgot a part of that. Hold on, you guys. Back up. Okay, outside of the absolute value, it's going to be absolute value 2 minus 3x, excuse me, plus 2 equal to 9. Okay, the reason I chose this example is because I really want to stress to you guys the part where you have to, before you can set it up or split it up into 2 separate equations, you really need to get the absolute value part by itself. So we want to get that by itself. We want to isolate the absolute value part first. Okay? All right, so what we have to do here would be subtract this 2 from both sides. Once we do that, we're good to go. Okay? So we end up with the absolute value of 2 minus 3x is equal to 7. And that's good, okay? As long as you don't have a negative, we need the absolute value to come out to positive, correct? If you would have a negative value on the right side, there would be no solution. Okay, but we do have absolute value equal to a positive or a 0, right? Okay, so now we know we're good to go. We can set it up, and we would take the mess inside. Don't change it. Okay, we're going to say, we take it out of the absolute value symbols and say 2 minus 3x could be the opposite of the right side, right? Or 2 minus 3x could equal the right side as it is. So this is how you'll set these up, the equations, every time, okay? It's when you get into the inequalities that it could go different ways, okay? This is every time for an equation. And then you have 2 different equations to go down the line and solve, right? Okay? And so let's go ahead and do that. We'll subtract 2 from both sides. And I'm going to go ahead and just kind of do this quickly. So if I skip or if I do something in my head, or I just say it instead of writing it, stop me and ask me to go back, okay? I need you to do that. So, okay, and then divide by negative 3x, so x will be positive 3 on this side. Okay, and here on the right, this equation, subtract 2 from both sides. Negative 3x, 7 minus 2 is 5. Divide by the negative 3, and x is negative 5/3. Now I want to take this, take a moment and just say, notice I left my answer as negative 5/3. That is fine. I actually prefer an improper fraction just simply to be in reduced fraction form. Instead of making it a mixed number, you don't have to do that for me. I'd like it to be in this improper fraction form. Okay? So, of course, you can go back and check your solutions, and I want to go ahead and just continue on to our next examples. So, all right, you know how to check. You can check by going in separately. You have to do these independently. You have to check 3 and then see if you get the true or false statement. Then you go and check the negative 5/3. Okay, so You have to check both solutions, but as if it's its own solution. You independently check them. Okay. All right, so let's scroll down, and I'll give some room here. Okay, so, oops, give us some writing room. All right, so, let's see, this will help. This usually gives me good room here. All right, so now I want to go into the absolute value inequalities. I know we kind of started to look at that the other day, but we didn't get very far. Just to remind you, in case you're just getting in, I think somebody just came in. We didn't get too far. I really didn't get to show you everything I needed to show you about that. So here we go. Let's do some of these examples I have right here. Okay, I want to keep your homeworks too kind of on top of my stack of stuff, so that I can kind of make sure I'm lining up with what you're going to see, especially for your midterm. Okay? All right. Okay. All right. So, all right, now let's go into this. Okay, let's have, all right, so this will be just examples to solve, okay, equations to solve. Okay, so I'm going to write this, solve. I don't need to write all the notes for inequalities, the absolute value inequality, because I did that the other day. So I'm kind of just going to example after example. I'm trying to get as many examples in as I can today. Now, I may even go into a separate skill. I'm going to start off with an absolute value or inequality, of course, or two. But I may put a couple of different ones in here just to kind of test you, have you test yourself. Let's start out with a greater than. Let's start with absolute value of 3x plus 1. Make sure I didn't do this the other day. Let me know if this is one I did already for y'all, please. I don't want to be repetitive. Greater than or equal to 10. Okay. Now, of course, it can't hurt to see it again. But we have greater than or equal to. That's going to be one that the solutions, wherever they may lie, they'll be shaded from the outside. Okay. So that's going to be two separate statements when you set it up, okay? Okay, there we go. So we need to do less than, the left side, the part in red there that's shaded there, right here. This is going to be the mess less than the negative. Okay, and then the right would be the mess greater than the positive. So we'll have 3x plus 1, as it is written, right, less than or equal to negative 10. Okay? And then we'll have 3x plus 1. Notice I didn't change the part inside of the absolute value. This could also be greater than or equal to the positive value. Okay? So now again we have two separate inequalities to go down the line and solve. Of course, we want to subtract 1 from both sides here. All right, goes away here. 3x less than or equal to negative 11. Divide by 3. It's positive 3, so nothing changes as far as the sign. Okay, so here's this solution. Now let's go down the line on the other one. Okay, subtract 1 from both sides. And we have 3x is greater than or equal to 9. Divide by positive 3, and x is greater than or equal to 3. Now let's talk about how these solution sets can be represented, okay? Let's take a look at this on the number line, okay? So draw a fresh number line here. Negative 11 thirds, and this is as simple as it has to be for me too. Look, I'm just position them appropriately with respect to one another, and then you can go into shading. So less than or equal to. So the less than part we shade to the left of, right? And then, of course, for the greater than or equal to 3, greater than, we shade to the right. Now, we said brackets would be what we use to include the endpoints. So in other words, negative 11/3 and 3 are part of the solution sets, as well as all the numbers on the outside of them. So this is what our solution set looks like. And remember, when we have something like this, our interval notation will kind of be similar. Okay, an interval notation looks like this. Comes up from negative infinity to negative 11/3. Include it with a bracket. Okay, leave a little space here. Okay, and then let's do this part. Okay, so that's this. So now this part will look like this. Include the 3 and through infinity. Between them, these are both part of the solution set, so we want to union, which is, it kind of looks like a capital U without the stick, without the kickstand on the side. Okay? And so this is the interval notation for this solution set. Okay? 3 ways to put the same thing in writing to represent the same solution set. Okay? All right, so we have graphical interval notation. Am I forgetting something? I don't think so. I think that's all. As far as I remember, I can't think of it any other way that right now offhand. But look, remind me if that's something else I'm not forgetting. Okay. I hate that when you feel like you're forgetting something. It's okay. All right, so let's see. That was a greater than. Let's do a less than. Okay. Here's one. This ought to be fun. Let's do 1/2. Uh-oh, fraction. Uh-oh, hot dog. Okay. Absolute value, 2x minus 1 over 3. Absolute value sign. Less than or equal to 1. Okay. Yeah, that's good. That's fine. Okay, so what's the deal? Someone tell me, what should I do first to this? Let's see. I got a hand up. Hold on a second. I'm getting to your questions. Okay, there you are. Nancy, oh, LCM. That's a good guess. I think we got one more thing we need to do, but that is the first thing we do, Nancy, once we start to LCM. We will need that. Isolate the absolute value. Very good. Thank you. Good job, y'all. You guys are kicking this morning. Wonderful. So yeah, first let's isolate. We want to isolate this thing, right? But Nancy, once we set it up and go into solving the independent inequalities, yes, ma'am, we will be using that LCM. You can use that to clear fractions. Okay, so let's do that. We want to subtract 1/2 from both sides. So we can kind of do like this. Okay. So moving on, let's see, this will go away on the left, and we'll have absolute value 2x minus 1 over 3. And actually, we might not even need to do exactly that. We will, though. We'll do that method for that. We will. I'm going to stick to that because it works all the time. I'm not going to go into anything fancy. Okay, let's set this thing up. Now we have less than the positive number. So this will be an interval. We'll have negative 1/2 less than or equal to 2x minus 1 over 3 comes out of the absolute value bars and is in the middle, right? And then less than or equal to the positive of what's on the right. Okay, so we're going to take an absolute, excuse me, not the absolute value, we're going to take the LCM of the denominators and we're going to distribute it on through, and it'll clear out all our fractions. And let's see, what wasn't it? 1/2 plus 1. Right, 1 minus 1/2. Look, I subtracted 1/2 from both sides, right? So I needed to get this guy off of that side. And so I subtract 1/2, it cancels here. And so this is the 1 minus, I'm subtracting the 1/2, right? You good now? You got it. What's the denotation on page 138 of the textbook? It was denoted as negative infinity. Didn't use the bracket. Oh, it did it. use closer. Okay, yeah, either sign, Michelle, you could, thank you for that. No, Stephanie, you got it now. That's cool. Sometimes it's odd. Stephanie, I'm glad you caught yourself. It's odd to look at that sometimes. It really is. And so, no, that's cool. Don't worry about it. But sometimes it takes us a minute. It happens to me, too. It's so cool. It's all good. Okay, so let's move right along. Let's take that 6 on through this entire thing, and let's go for it. Let's have this -1/2, and I want to hurry up and get these done. I want to do some of these word problems, you know, so let me hurry up. So we're going to take a 6 through. Everything's going to get multiplied times 6. Okay, let me see. Yeah, let me do this. Use a parenthesis. Less than or equal to 6 times 1/2. Okay, so 2 goes into itself once, into 6 3 times, so I'm going to have -3 on the left. Watch your signs, too. It's at this point when simple mistakes get made, you know, so just be very careful. Take your time, especially on that midterm, you know. You want to make sure, for example, this step, wait to distribute that 2, for example. We got rid of the fraction in one step. But go ahead and wait to distribute if you want to. I mean, it's up to you. Totally up to you. Of course, 3 times 1 is 3. And I like to separate it out so I don't make, personally, so I'll make a lot less errors just trying to hurry. You know, I don't want to hurry through. So I can, it just takes more time to go back. So 2 times 2, 4x. 2 times -1 minus 2. I don't know if that came out right, but okay, if I said that right. Okay, guys, so now let's go ahead and go through the process. We want x to be in the middle, so we're going to add 2 to all sides. I always have it say both sides, but it's all 3 sides. Okay, so we'll have -1, and then the 4x. These guys cancel. Less than or equal to 5, okay? And now we'll divide everything by the 4. And it's a positive 4 we're dividing by, right? So the signs are not going to change. So -1/4, less than or equal to x, less than or equal to 5/4. Okay. So let's see. Let's go here, and I'm going to go ahead and just I'm going to use the interval notation. And so, yeah, the brackets should include the endpoints. That's standard. That should be for any textbook you have. Oh, wait, that's just not that. Hold on. Timeout. Sorry. This is going from this solution set is between -1/4 and 5/4. So it's just here. So 1/4, and we want to include them, right? So brackets, squared brackets. -1/4 through 5/4. Close with a bracket. The brackets include the endpoints. In other words, when you have or equal to, less than or greater than or equal to. Okay, and then of course parentheses exclude. Okay, parentheses exclude. Endpoint. Okay, just so that you have that written down somewhere. Okay, let me go into this. Let's see. On this topic, does anybody have a specific thing? So let's see. By the way, they label them as conjunctions and disjunctions. Let me go ahead and show you what I'm talking about. For example, let's see. They may say solve the conjunction, okay, for something like this, the intervals here. Let me highlight what I'm talking about. So they might give you a problem that looks like what I'm highlighting here in the blue. And say solve the conjunction. So that's all this is, okay. It's an interval. It's another way of saying the same things. More than one way, like I said earlier, there's more than one way to solve these. There's more than one way to label them as well. Okay, and then they also, the disjunction is like A, okay, so they'll call this one a disjunction. So when you have greater than, and actually they're kind of telling you what to do in this regard. If you think about disjunction as disconnected, right, this would be a disjunction. Okay, and then of course this guy is a conjunction. Okay, so FYI, that is the 411 on that. Okay, let me see. All right, I want to take a minute. I'm going to do this a word problem. Let's kind of do some of this stuff. I'm thinking that you guys should be okay for your homework 5 with all that I've done so far. Of course, let me know if y'all have more questions on the absolute value inequality stuff. We don't have but 20 minutes left. I'll have to keep this under an hour. Okay, when a variable is in all 3 areas. Let me see, like numbers 19 and 20 from the homework. Let me take a look. Let's see. 19, 20. Yeah, I can show you that. Let's see. Okay, that's a good question. I'm going to do one very similar to 19 or 20. I do have a problem handy that I can show you. Thank you for asking me that. That's a very good one. Good question. All right. So let me get that out here. Okay. All right. My papers keep slipping out of my hand. Okay. Some moisture. Okay, guys, so that's a good one. Thank you for that. Shows me you guys are listening. I appreciate that so much. Okay, let's give me a little space here, and let's do that. So this would be example C, I suppose. Okay, let's have absolute value of 9x plus 2 is greater than or equal to x minus 1. Okay. So, okay, yes, I just kind of made one up, like, so we'll see. I kind of made it very similar to 19 and 20. So we'll see what happens. Okay. You do the same thing. Okay, we have the absolute value symbols isolated on this side. So we see then that we have the greater than symbols, right? So this is a disjunction. And are they spelling that with a Y? No, an I. So this is a disjunction, similar to part A above, right? Okay, so kind of keep that in mind. A greater than, in other words, is going to be below the negative and above the positive. Now, when I say the negative, instead of the negative, let's say the opposite of, okay? So here we go. This is the setup. We want to take our mess just like it is, 9x plus 2. Going to be less than the opposite of this, the right side. So just write that, the opposite of, and in parentheses, copy down what's there. So it's like saying negative whatever, okay? So we'll get to that in a sec. So let's go to the next statement. We're setting this up properly, and then we're going to go to independent inequalities, and we'll solve them independently. As is, take the mess out of the absolute values, mess, above the positive, right, or above as it's written up here, right, x minus 1, as is. So below the opposite, above the problem as it is, or the positive if you want to call it that. Now, this is where the difference is made, okay? So the opposite of, we take the opposite of by taking the opposite of every term. So we distribute that negative. And you want to handle it like that systematically, because anything you have in this format, you can handle it if you think of it as the opposite of, and put that negative and write the parentheses. In the first step, you'll come down 9x plus 2 less than, and you distribute the negative. The opposite of x, the opposite of negative 1 is positive 1. You see that? And continue to solve. Simple as that. Okay, so let's add x to both sides. Okay, so we'll have what? 10x plus 2 less than, of course, these guys go, and then 1. Subtract 2 and continue on. So 10x less than negative 1. Okay, remember we just subtracted the 2. That doesn't change the direction of our sign, right? We haven't even seen an example yet where we have that happen. So keep in mind, I'll try to put one up there, by the way. Next, I'll try to put one that includes it really quick. Divide by 10 less than negative 1/10. So let's go to the other way. Let's go the other direction, the greater than the positive, and solve it. So subtract x, subtract x. So 9 minus 1, we have 8x plus 2 greater than, these guys go, negative 1. Subtract 2 from both sides. Again, we're just subtracting a 2. That doesn't change the direction or the sense. Okay, these guys cancel. 8x greater than negative 3, and of course now now x is greater than negative 3/8. All right. Let's take a look at the solution graphically. Now, negative 1/10, okay, and then negative 3/8. Okay, all right. So x is going to be below negative 1/10. Okay. Now my thing just disappeared. Hold on. Let me get that to come back. Come back. There you go. Less than the negative 1/10 and greater than negative 3/8. Okay, let me do something really quickly. While I'm taking a little pause and writing, you guys write the interval notation. Let me check my... This is when I would actually use a decimal form. I would actually check the decimal values to make sure I'm putting these guys in the right position on the line. That's all I'm doing right now. So let's see. Negative 1/10. Okay, let's see. We're in the negatives. I'm just making sure I have them in between the right, or just in the right position. So let's see, 0.37. Let's see, it's 0.5. So 0.375 would be here. This is the 3/8. And then negative 1/10, 0.1. So there's something odd going on here. So let's see. I'm going to see. Let me go back. Do y'all see any mistakes I made? Have I made any mistakes? Okay. Nope. Okay. So let me do this now. Minus 1. Okay, so that is going to be bigger. So I have these guys kind of out of order. Have y'all noticed that? I don't know if y'all noticed that. These guys are out of order. In other words, 3/8, negative 3/8. Oh wait, it's negative though. This is fine. Let's just leave it at that. I'm going to come back to this and I'm going to check on this solution. I think everything's done correct. We haven't made any silly mistakes. So let's leave it at this. I'm actually going to stop here. I'm going to let you guys know part C. I'm going to go check this, okay, because I made it up. Okay, so I'm saving the rest of this one for later. Everything else, we set it up correctly. The conjunction is set up, disjunction is set up correctly. There's no mistake in that. Please don't fear that. Everything else is fine. Remember, I just made this, I changed numbers around to make it look like your problem, so I need to come back and make sure I didn't like mix these numbers up, that's all. On the number line, directionally, it's strange to look at a fraction, and I'm trying to hurry, so. Let me come back to that one later on today. If y'all would like, I'll post something on the general forum about this. So I'll give you guys the final solution on that. Let's move on, though. Is that okay with you guys? It's fine? Hopefully it's okay. Let me see. I'm trying to see your questions. Does anybody have any questions about anything? Is that fine? Oh, there's the questions. Okay, cool. Thank you. Okay, guys, so let's move on from that. But that is basically how you'd set up the 19 and 20. This is the important part for that is up here in these first few steps. That is the setup. Okay, so let's do one more and we'll keep going. Let's see. I had a good question from someone the other day. It was a really good one. So let me kind of find that. I think I might have done, I posted it. I did a video on it, I think. I'm not sure if it got put up, though. Here it is. Okay. Okie doke. This is similar to that, by the way, okay? So this is where we have an absolute value. You may have a situation where you have absolute values on both sides. Okay, so if we have this, absolute value 3w plus 2 is equal to absolute value w minus 4. Now, this is just an equation. This is not an inequality, so kind of keep in mind. If you have a midterm or a test like that, they may put these guys all together, like all the absolute value stuff might be together on a college GRE or an exam in that, the large exams like ACT and all that, they would do this too. Now we'll handle this one similar to the previous one, whereas we're going to set it up equal to the opposite and equal to the as is right side. So we're going to treat this like the mess. The left side will be sort of like the mess. And we're going to treat this as though it's just a set of parentheses. Okay? So what happens to this problem is the setup is like this. I'm having trouble setting up 11 and 12 in the homework. Okay. I hear you, Brianna. On homework 5? You're talking about 5, right? Okay. All right, I'm going to come to that next then. So real quickly, we'll have this mess. Oh, excuse me, I'm trying not to write mess. I need to write the 3w plus 2 as is equal to the opposite of w minus 4, right? So that's like saying the negative, right? Okay, and then 3w, hey Linda, good to have you, glad you got to come, and equal to w minus 4 as it is written in the problem. So now we'll go independently. So first off, we want to distribute that negative. So we'll have 3w plus 2. Now we'll have the opposite of w and the opposite of negative 4. So negative w plus 4. Of course, we want to add the w to both sides. We want to get all our w terms on the left, or let's just say on one side of the equal sign, right? So we have 4w. And you can subtract the 2 from both sides as well. And so we'll have 2 divide by 4 and simplify it to 1/2. Okay, so there's one solution. Alrighty, so now the other side. Let's go here and we'll have subtract the w. So we'll have what, 2w? And we can even subtract 2 here. I'm only doing both of these in this first step, like one step, because now you guys have kind of had a lot more experience. And I trust that y'all will stop me if you get confused, but I think you guys know what I'm doing when I do that. Okay, so here are my solutions. You do want to go back and check them. Okay, you have to check them independently, right, to check. Or if you have a problem that says to verify if 1/2 is a solution to this equation, something to that effect, like you've seen recently in your homeworks. Let's check w equal to 1/2, just to kind of give you guys experience with that. So we're verifying that 1/2 is a solution. Absolute value, 3. Now we want to put 1/2 in the parentheses here. Okay, plus 2. Absolute value equal, absolute value 1/2. We're only dealing with w equal to 1/2. We're not touching the negative 3 at all right now. Just 1/2 gets plugged into the entire equation. And you come down and look for a true statement, right? So now we have what? 3/2 plus 2, or what is 2? 4/2. Unfortunately, you do have to kind of do that, the common denominator, but it's not that bad. Okay, is equal to, and so what do we have here? We have 1/2 minus, look, this is 4/1, so 4 times 2 is 8. So that's not hard to do. 7/2 on the left. Okay, and then on the right we have what? -7/2 in the absolute value. We haven't taken the absolute value symbols off yet, right? So now 7/2 is equal to 7/2. Oh, excuse me. So it checks out. This is true, and so that is a good solution. That is included in the solution set. 1/2 is correct. So you guys, I guess what I'm trying to show you by showing you the check is, remember, you have a key. You have a key. If anything you got to solve, including the inequalities, you can go back and plug those in and see if you get 0 is greater than -1/2, for example. And if it's true, you got the problem. You solved it. Or if it's not true, it's not a solution for other reasons. Okay, it could be that it's not in the domain. We're going to get to some problems where you want to check them, like you have to go back and check them for other reasons, so because they wouldn't be in the domain. And we'll talk about more about domain later on. I don't want to put that in your head before midterm. I'm going to leave you guys to check W equal to -3, but I'll do the plug-in here for you. Here's the plug-in. Absolute value 3 times -3 plus 2, absolute value equal absolute value -3 minus 4. Close, yeah. So you'll go down the line and check this. Actually, it's so quick, I'm just going to do it. All right. -9 plus 2, -7. Absolute value -7 on the right. Of course, 7 is equal to 7, so that's true. And -3 is a solution. Okay, I underestimate myself sometimes. Sorry, I'm trying to hurry. So that's good. But you guys can go check other problems. Okay, I want you guys to check the first couple of ones we did, just to practice. Okay. Alrighty. So let me get to that question you had. Check we can plug the values into any of the steps. Yeah, you can, Stephanie, but I would go, I actually have a solution in the solution set 3 where I did that. I actually simplified that really long one. I think it was number 3 actually in the homework 3, where it was verified that 7 or something like that was a solution. Wherever lecture 3 homework number 3, the one I'm about to post. But I did that. I actually simplified it a little bit before I plugged it in. You know what I mean? I wouldn't go down to 4W equal 2 when you're that far down the line, because you could have made mistakes in your simplification. You're going to have to be the judge, but at some point you do have to plug it in. So I'm going to let you be the judge on that. But, definitely you can simplify it, get it boiled down, to maybe eliminate fractions or something, Stephanie, just to kind of simplify it a little bit. But yeah, you could, because they're all equivalent equations and have the same solution. Any step should work. Okay? Hopefully that helps you. Okay, on the homework 11 and 12, yes. Okay, let's take a look. So, let's see. So, Brianna, yeah, I was about to do word problems for you guys. So, let's take a look at something similar to 12. So, this is due today, so I can't do anything exactly like it. So, I will do something similar. Let me see. I have some problems here. Let me get this one out that I have. I tell you what I can do. I'll do this one. This will help you. All right. So this will be from lecture 3. There are some problems in there that could help. It's very similar. The setup's pretty similar to that. So the cell phone bill. Okay, let me see. We don't have, oh shoot, we're running out of time. Doggone it, doggone it. Mr. G needs us to stop right now. I tell you what, guys, Brianna, we're going to get cut off here, but I am going to, let's see, would it be okay if and I'm going to get this up as quickly as I can, but would it be okay with you if I post one? I'll go record one quick one for you. And I am about to post all your solutions. You'll see the solutions to number 5 like pretty quickly. Probably today or tomorrow you'll see all of them up. Okay, so you guys listen up. Let me tell you this. I will have these solution sets up probably before your grades go up, because I'm trying to give you guys all these solution sets so that you can compare your work. But I want you guys to, you know, focus in on what you need to focus on. Unfortunately, I'm running out of time. I'm so sorry about that, Brianna. But look, yeah, thank you, appreciate it. I'm gonna help you with that. Actually, if you want to set up an appointment with me, we can look at some of these together. But you guys are welcome to call or text if you're stuck on something, especially once I've posted the key, you know, the solution key. If you're still stuck on like how did I get something, a solution, or how did I get to a certain point, call or text me. We're preparing for a midterm, which is weighted a little more than our regular assignments. So not to be nervous about it, but you know, I understand the gravity of the whole thing. You guys, we're going to get this done. You guys know that you can contact me. You're always welcome. I guess this is it, though. I have to cut us off now. I'm so sorry I got to do that. I wish I could spend the whole day doing problems with you guys. I can't. Y'all have a good one. Get in touch with me. Don't be afraid to call me or text me. I can't put my phone number on here right now because it's going to be online, so I don't want the world to call me. All right, you guys. Have a great day. Be in touch. Let's see. Okay.